Hello, myself Susabun Ray. Today I am going to discuss the timing diagram of Intel 8085 microprocessor. So, so what is timing diagram? So it is basically nothing but the flow diagram. The necessary steps which are carried out in a machine cycle can be represented graphically is called timing diagram. So there are five basic machine cycles are there. Number one is opcode fetch, where 4 T states are required. Second one is memory read, 3 T states are required. Then memory write, IO read, and IO write. All of these, uh, 3 number of T states are required to do such kind of operation. The next one is the opcode fetch. So opcode is one of the operational code uh, for each and every instructions have an opcode we have already discussed. So each processor instructions has a 1 byte opcode. Okay. So and this opcode basically stored in memory. We have already seen in last lecture where the opcode is basically stored, and we have already seen how the instructions and data is flow. So opcodes are nothing but they are basically operation code for each and every instructions, and they are basically stored in memory. So this is the flow diagram for opcode fetch, and here you can see there is a clock signal is required, and the number of T state is required for opcode fetch is 4 T states. Okay, so the next pin for opcode fetching or any kind of timing diagram, so this kind of pins are basically available. Number one is clock pin, then A8 to A15, which is called the higher order address pin of 8085 processor. ALE, address latch enable pin. AD0 to AD7, this is called lower order address. And here the address and data both are in multiplexing form. Next one is IO/M bar, input output and memory related pin. Next one is S1 S0, these are indicating the status pins, and last one is the read pin. So basically the first T states are used to load the opcode from the memory. So if we focused on the first 3 T states, we can conclude that the higher order memory address are loaded over there whenever the A8 to A15 pins are activated, and whenever AD0 to AD7 pins are activated. In that case, the lower order address will be passing at T1 T state. Okay, and the opcode will passing from T2 to T3 T states, and here the ALE pin which is shown over there, and that will be activated whenever lower order memory address will be passing. So that means at T1 state the ALE pin is goes high, otherwise it is goes down. IO/M bar pin is basically representing this operations is memory related operations or IO related operations. So whenever S0 and S1 1 in that case the processor could perform opcode fetching operations. So obviously both of these pins are goes high, that is shown over there, and IO/M bar pin is equal to 0, that means obviously this is memory related operations. So now the read pin, which is active low pin, so that is why whenever the opcode or the data is passing uh, from T2 to T3 region, in that case it will be activated, otherwise it is in the activated mode. So that is all about for opcode fetching. So the next one is memory read machine cycle of Intel 8085 processor. So the data are basically depends upon the memory read machine cycle is basically executed by the processor to read a data from the memory, and how many T states are required for this particular machine cycle. There are three number of T states are required, T1, T2 and T3, and same thing is happening over there, but here we have to focused IO/M bar pin and S1 S0, which is called the status pins. So in case of read operation, S1 equal to 1 and S0 equal to 0. So that is why S1 pin is moving upward directions and S0 is 0. So that is why this flow diagram is representing at the falling edge. Okay, and IO/M bar pin is 1. So that is why this is IO related operations. This is not memory related operation. And the read pin is active low pin, and this pin is activated during the T2 and T3 T states region. And similarly the ALE pin that is also goes high at T1 T state because the lower order address is passing during this time. Now this is memory write machine cycle. Here you can see instead of read operations, the write operations could be added over there, which is denoted by WR pin. And here the same phenomena is happening as we have seen for read operations. So whenever the data is passing, in that case the write pin is activated, and this is active low pin. So that is why whenever WR is equal to 0, then it will be activated. Otherwise it is in reset conditions. Now this is for input output read machine cycle, and here it is performed by the processor to read a data byte from an input output port or any peripheral device or the external device which are basically connected with the main processor. And here the required key states is also 3, and this is for IO write. And for IO write, the processor to execute a particular cycle, the processor to write a data byte on the input output port, and that is a reverse operations of read operations. And here the required T states is also 3 to execute a particular machine cycle. And instead of read pin, here the write pin will be engaged and it will be activated. Whenever it is goes low, then it will be activated, or you can say whenever the data will passing, then it will be activated. Okay, thank you.